Alright, now comes the time to create a road for our runners to run on. So to do that, we are first going to create a new 3D object, which is going to be a cube. Okay, perfect. So for now, let's hide or remove our plane. So the cube will be a little bit lower. So I think minus 0.5 on the y-axis is pretty good. Let's make it 10 units wide for now and maybe 10 units long. Okay, perfect. We can also press T to get the rect tool and make the cube a little bit longer. Okay, perfect. So this is our base road. So let's call it a chunk. Okay, perfect. Let's call it chunk renderer. Nice. Let's make this chunk renderer a child of another game object, and let's call this game object chunk. Perfect. So I'm doing that to be able to spawn multiple chunks later on, make our road procedural or more random if you wish. Okay, cool. What we need to understand here is that we are going to have multiple sizes for our chunks. So maybe this one is going to be short. So let's call it short chunk. Let's make another one and move it a little bit on the x-axis. This one will be longer, so let's call it maybe, let's set it 20 units long for now, or maybe no, 20 is good, and let's call it medium chunk. Then we can create another one, move it a little bit on the z-axis, set it to 30 units long on the z-axis, and we can call this one long chunk. Okay, perfect. So when creating the prefabs, we are going to drop our doors or gates and enemies on these chunks. Okay. Then we will have another game object which will hold a chunk manager script and will be responsible for creating the road procedurally. Okay, I hope this is good. So in this case, we need a little script attached to our chunk to know the exact length of our chunk. Perfect, let's do that. Okay, so here open the scripts folder and create a new script called chunk. Okay, so let's select our short chunk and drop the chunk script on it. All right, let's open it. First off, we want to create a new header again for our settings. Let's create a new property with a serialized field to show it in the inspector. It's going to be private. It's going to be a vector 3. All right. And let's call it size. Perfect. Then we want to be able to visualize our size, the size of our chunk in the scene view. So for that, there is a cool method called onDrawGizmos. So when drawing the gizmos, Unity will call this method. So you can implement this method in any of your scripts and draw whatever you want. So in our case, we want to draw the size of the cube or of the chunk. So first off, let's select a color. So let's say gizmos.color equals maybe color.blue. Not black for now, but blue. Okay. Then we want to draw something. So we are going to draw a wire cube. It's just the outline of a cube, basically. So let's say gizmos.drawWireCube. This takes as argument the center of the cube and the size of the cube. So the center of the cube will be the position of our chunk. So let's say transform the position. And the size of the cube will be our size. Okay, perfect. Let's head back to Unity and check if this works. So this is a chunk. Let's set the size to 10 on the x-axis, maybe 10 on the y-axis, and you can already see that we have a blue outline right here. And on the z-axis, let's say 10 units. Perfect. This encapsulates our chunk on the z-axis. Don't mind the x and y. I know that this is offset on the y-axis, but it's not an issue for now because we only need the Z component here. The X and Y is just for a better visualization. Okay, click on the three dots here and copy the component. Let's select our medium chunk and pass the component as new. All right, now we just need to make our length 20. All right, same thing here, pass component as new for the long chunk, and let's set the Z value to 30. Perfect. We now have our chunks to work with. But when making our chunk manager, we will need to get this Z value. So let's create a quick method here. It's going to be public. It's going to return a floating value, which will be the length of our chunk. Okay, so it will simply return the size.z. Awesome. In the next lesson, we are going to create our chunk manager and create our first road the runners can run on. Let's go. All right, guys, let's create our chunk manager now. So first off, let's open the prefabs folder and create a new folder called chunks. Okay, this is where we're going to store all of our chunks prefabs. So let's drag the short one, the medium one, and the long one. Okay, perfect. We can now remove them from here. Cool. Under the gameplay game object, create a new game object and call it chunk manager. All right, cool. Let's open our scripts folder and create a new script again for our chunk manager. Okay, let's open it. Chunk manager. Perfect. So first off, let's create a elements header as usual. And then we want to create a new serialized field. It will be a chunk object. And let's call it chunk prefab. So for now, we are only going to use one chunk prefab. Okay. So at start, just as a small test, I want to create a bunch of chunks. So let's create a loop and I'm going to create, let's say 5 chunks. So to create a prefab at runtime, so in the start method or in whatever method you want, we need to call the method instantiate. Okay, perfect. So what do you want to instantiate? We want to instantiate a chunk prefab. So let's write it here, and it's going to be under this parent. Okay, so now if we hit play, the chunk manager will create 5 chunks under they will be its children. Okay, let's drag our chunk right there. Let's select the chunk manager and drag the short chunk here. Let's hit play. Perfect. We now have 5 chunks, as you can notice here, but we need to move them on the z-axis, like so. Okay, so let's try and do that now. Let's go back to the chunk manager. Before instantiating the chunk, we are going to create a new variable called, it's going to be a vector3 first, and it's going to be called chunk position equals, let's say, vector3.0. Okay, so we want to offset the chunk position on the z-axis by the length of the chunk. We are going to create the first chunk at vector3.0, so the origin of the word. But here the z value of our chunk position, so let's say chunk position.z, should be equals to the index of the chunk multiplied by, let's say 10 for now, or let's say 15, just so we can see some spacing between them. All right, let's assign this position to our chunk. So let's say chunk position, and we also need a rotation for that. So let's say quaternion.identity. So quaternion.identity here is just the base rotation. The angles will be 0, 0, 0. It's not rotated at all. Okay, let's go here and hit play. Perfect. We can now see that our chunks are distributed on the z-axis. Okay, but now we need to get them stuck. Okay, so what are we going to do here? First, we need to grab our chunk position and drop it here because we need to save it for later. We don't want to initialize it every time on the loop. So whenever we create a chunk, here what I'm going to remove this line first. I want to save the data of this chunk. So let's say chunk instance equals instantiate blah blah blah. Now we have a reference to our chunk instance. So whenever we create it, we want to increase the z value of the position by the length of the chunk. So chunk instance dot get length. That way, after creating one chunk, we are going to create another one just after this one, and they are all going to be stuck. Okay, let's hit play. Perfect. You see, now this one is at 10, this one is at 20, 30, 40, and so on. And what's cool about that is that we can add multiple chunks here, multiple chunk prefabs, and the road will be created properly. So let's try this. Instead of having one chunk prefab, let's add an array of chunks. So let's say chunks prefabs here. Okay. And now when creating our chunk, we want to say chunk to create. So it's going to be the prefab equals chunk prefabs. And here we're going to grab a random index in the chunks prefab array. So let's say random dot range between 0 and the length of our chunks prefabs. This will allow us to grab a random index between 0 and the length of our prefabs. So as this is an integer, if we have 3 prefabs, it's going to go from 0 to 2. Okay. So now we just need to grab this one, and this is the object we're going to create. Okay, let's go back to Unity, develop the chunk prefabs array. Let's right click on the chunk manager script and select properties. That way, if we go to the projects tab and select anything, we still have this window opened where we can drag and drop our chunk prefabs. Let's now select our 3 chunks, drag them and drop them into the chunks prefabs array. All right, we can close this, hit play. And this is not working. So why isn't it working? It was working previously because all of the chunks had the same length. Because instead of adding the length to the chunk position each time, we need to add half of the length of this chunk plus half of the length of this one. So let's fix our issue here. Here in the chunk position.z, we are going to be adding half of the length. But before creating our chunk, if we already have creating the first chunk, so if the index I is greater than 0, we want to add the chunk to create. So the chunk we are going to create dot get length divided by 2 to our position. So it's going to be chunk position dot z plus equals the half of the length of the chunk we are going to create. And this will hopefully fix our issue. Let's hit play. Perfect. This is exactly working as intended. Now we can have variable chunk lengths and still work with them. Let's control our runners a little bit here. All right, perfect. Oh, issue here. You can see that the runners can go outside of the road, and that's bad. We will fix this in the next lesson. All right, guys, we've done so much to this point that I want to create a small chill lesson. So in this lesson, we're just going to fix the players or the runners going outside of the road and improve the graphics a little bit. So first things first, let's open the materials folder and create a new material for our runners. Okay, let's say runners or maybe just runner. Then you want to open the runner prefab right here. Okay, let's only select the body, and under the materials tab here, change the material to our runner material. So where it is? Here it is. Perfect. Now we can go back to our hierarchy, and you can notice that if you change any property on the runner material, it automatically changes the material of all of our runners. Perfect. So let's color them maybe bluish. And it's not clear enough here because we still have a lighting thing that we did not talk about. And this is the fog. So to disable the fog, click on the window tab, select lighting, rendering, and lighting. Okay, let's dock this window right next to the inspector. Click the environment tab and disable the fog. Perfect. You can notice the difference when enabling and disabling it. Okay, let's disable it for now. Then we can select our runner material and add a little bit of emission to diminish the shadow effect right here on the right. So let's add some emission. Maybe it's going to be some bluish emission. Okay, perfect. This is great. Then what we want to do is to bring the camera back a little bit because it's too close to the runners for now. So let's select the Cinemachine camera and increase the Y offset right here, and the Z offset, diminish the Z offset like so. All right. On the aim component, increase the Y value a little bit to have a better view of what's in front of us. Let's hit play. And perfect, we already have a better view here of the runners and so on. Cool. Now we want to improve the shadows a little bit here. So what we're going to do is click on Edit, and select Project Settings. Okay, let's dock this window next to the lighting window. Perfect. Let's make it a bit bigger. All right. Select Quality. And when selecting quality, in the quality level, select medium. This is better suited for mobiles. Then click on the Unity RP medium quality asset. Select it and go to the inspector tab to view its options. Okay, now let's just drag a temporary chunk right here to be able to see the shadows. Okay, now we have a better view of the shadows of the runners. So let's go back to our universal RP asset. It's in the settings folder, medium quality, okay? And here you can play a bit with the distance of the shadows. So when decreasing it, further objects won't have shadows, but closer objects will have clearer shadows. So for mobile, it's better to keep the cascade count to 1 or 2. So the cascade count will make transitions between close and far objects. All right, so you can improve the distance, but set the first cascade to something like 20 meters, and it's already pretty nice. All right, now we want to diminish the strength of our shadows. So select the directional light and diminish its strength. All right, now that's better. We're getting somewhere. Then let's assign a new material to our chunk here to have a better contrast between the chunk and the runners. So let's go to the materials folder, create a new material and call it maybe ground. All right. Now let's select each and every chunk. So for this, select the chunk we just created, click on select and open the short one. Select the chunk renderer and under the materials property, select our ground material. Same thing for the two other ones. So like so, ground material and long chunk renderer, ground material. All right, we now have a ground material assigned to all of our chunks. So let's change the color of the ground a bit. So open the materials folder, ground material, diminish the smoothness of the material, and maybe change the color to something so opposite to blue to have a better contrast. Maybe a bit dark to better see the players. Maybe some brownish color. Yeah, I think that's pretty good. Maybe you can use something like dark blue, or yeah, we still have a good contrast like so. All right, but let's use let's use this brown color. Okay, perfect. Next, we want to add some kind of water just for now. We will improve it later, but let's create a new plane. So 3D object plane, and let's call it water. Okay. We can remove the mesh collider because we won't collide with it. So remove. Let's bring it down a bit. Okay, let's make this window smaller and the scene a bit bigger. Okay. Let's increase the size of our water to something like 100 and 100 on the z-axis too. Maybe we should bring it up a bit. All right. Then we can create a new material for our water. So let's create a new one and call it water. You can drag and drop it onto the water to assign it to it. We can remove the emission from it and make the color maybe a bit darker, or yeah, this blue seems nice. Perfect. Now if we play the game, so let's maximize the game window, play the game, and yeah, it's much better. You see, it's more satisfying to play now. Okay, cool. Let's hit play again, and let's see how we can clamp the position of the runners on the x-axis. Okay, let's hit play. So for that, we want to select the player game object and open the player controller. Okay. So first off, we will need a reference to our crowd system because we want to know the exact radius of the crowd. You remember we made the crowd using the Fermat spiral, and now we want to know the radius of that spiral. So let's say elements. Let's add a serialized field property for our crowd system. Okay, and let's call it crowd system. And inside the crowd system, let's add a new method that will return the radius of our crowd. So here we are going to write a quick function to get the radius of the crowd. So it's going to be a public function. It's going to return a float, which is the radius of the crowd. And let's call it get crowd radius. All right, perfect. Then we know that the radius of the crowd is the radius of the Fermat spiral we used here. So let's just return this value, copy it. Let's write return this. And here, instead of using the index, we want the total amount of runners we've got. So it's going to be runners parent.child count. As easy as it is. All right. Now let's go back to the player controller. And on the line we've just written right here, we are going to take into account the radius of our crowd. So here we want to add the crowd system dot get radius, crowd radius. All right, let's hit enter right after the comma, and here we want to subtract it from the right bound. So let's say crowd system dot get crowd radius. All right, now we should see that if we hit play, the crowd cannot cross the right bound of the road nor the left bound. Perfect. We can also increase the amount of runners, so select all of them, duplicate them a bunch of times, and you can see that it's not crossing the right and left bound. Awesome! In the next lesson, we are going to see how to add the doors to be able to increase or decrease the amount of runners along the road. Stay tuned! Alright guys, in this lesson, we are going to see how we can set up the doors the player will cross. Okay, let's get right into it. So let's remove this. No, let's skip this chunk for now. And let's create a new empty game object. and call it doors. Okay, this will be the object holding our doors. So let's make the scene view a bit bigger, like so. Okay, perfect. First, we are going to create the side and the middle pillars. So let's create a new game object under the doors object and call it pillars. All right. Let's create a new cylinder. Here it is. Let's put the doors a bit further on the z-axis so we can see them. Okay, nice. Let's grab our pillar and drag it up a bit, like so, and diminish its scale on the x and the axis. So let's say 0.3 and 0.3 on the z-axis too. We can also increase its scale on the z-axis a bit for it to be taller, like 1.5. Yeah, maybe 1.5 is good. Okay, perfect. So this is the center pillar. We can remove its collider. We won't use it for now. All right. Let's create two more pillars, one on the far left, so -5, or maybe -4.9. 4.8 is better, okay, on the x-axis, and the right pillar is going to be at +4.8. Okay, cool. We have our 3 pillars. Let's close this. And now let's create another object which will hold our doors. So let's say doors renderers. Okay. So now we need to create a gradient in our photo editor to be able to use it for rendering the door. So let's jump to Affinity Designer or Photoshop or GIMP or any software you like. Okay, let's create a new square. Perfect. Maybe let's make it 256 by 256 because it's going to be rendered quite big here in our scene. Then we want to create a white gradient like so. So there is a gradient tool. There should be one in Illustrator or Photoshop too that you can use. Nice. We have our vertical gradient. Let's export it. Okay, let's call it vertical gradient. Perfect. Let's jump back to Unity and we should see it in the sprites folder. Perfect. So same as before, we want it to be a sprite and apply the changes. Okay, now we can just drag it and drop it onto our scene. Let's make it a child of the doors renderer here and let's reset its z value to 0. Now we can place it a bit better like so. Okay, maybe at the center of the right door, and we can stretch it. Okay, cool. So it's not at the center, so let's put it at the center, maybe like so. Stretch it a bit more. Here we go. Perfect. Okay, nice. Here we have our first door. Cool. The advantage here is that we can color it as we wish. So it will be blue for the positive bonuses and red for negative bonuses. This will give a better indication to the player. Okay, let's set it to blue for now. And let's create the second one. So Control D and let's hit -2.4. Perfect. We've just set up our 2 doors. We can rename them to right door renderer. Okay. And this one will be left door renderer. Cool. Let's now add some more indications to the doors. And this will be the Text Mesh Pro component. So let's add a new Text Mesh Pro to the right door, for instance. And here you can see that it's stretched because its parent doesn't have a proportional scale. So this is bad. We are not going to put the Text Mesh Pro here. So let's take the Text Mesh Pro and drop it maybe right here above. And we can change the scale to 1 and 1. Okay, perfect. And to fix our previous issue, we are going to create the doors separately. So right click on the right door and set create empty parent. Okay, so now we have a parent for our right door. We can drag our text mesh pro created previously and drop it under this new game object. Let's remove the left door for now. We can rescale our text mesh pro to something more convenient, maybe 4 on the x-axis and 2 units on the y-axis. Okay, same thing as previously. We can change the font to the Milky Coffee one we've downloaded and maybe just add a placeholder text. Tick the auto size checkbox. Okay, increase the maximum size and diminish the minimum size. Let's center it a bit. Okay, I think we're good to go. Okay, let's bring it a little bit back to render it before the gradient. And yeah, here we go. Let's now rename this game object to right door. Okay, and let's create another one and let's call it left door. Okay, we can move all of the elements of the doors. So maybe this one will be on the negative side and same thing for this one. Perfect. We now have our doors. In the next session, we are going to see how to add the logic to these doors to be able to interact with them. All right, guys, here we are. We've just set up our doors and now we are going to set up their logic. So now open the scripts folder, right click and create a new script. We are going to call it doors. All right, perfect. This script will hold the logic for our doors. So we will want to change the texts right here. They will hold the operation in some sort. So the multiplication or addition, difference or division. And we will also control their colors from there. So let's grab the doors script and drop it into the doors game object. Perfect. Now let's open it. So first off, we want to create an enum. An enum is just a data structure that holds some integers in a string form. So let's say I can create an enum called bonus type. And here, instead of having integers like numbers, 1, 2, etc., I can set strings or identifiers. So I'm going to create one for the addition, one for the difference, and let's add the multiplication and the division later on. All right. So next you want to create an elements header where we are going to reference all of our elements. So first off, we are going to write private sprite renderer, right door renderer, let's say. All right. Same thing for the left one. So left door renderer. And we also want to add the text mesh pro texts. So these ones right here. So let's do that. If you remember well, we need to specify the text mesh pro library. So it's using TM Pro. Then we can say private text mesh pro right door text. All right. Same thing for the left door text. All right. We now have all of the elements we are going to work with. Next, let's create a new header for the settings. Okay, so it's going to hold a serialized field, a private variable of type bonus type. So this will be the right door bonus. Okay, or let's say bonus type. We can do the same thing for the left door. So let's say left door bonus type. And between them, so right here, for instance, let's create a new private integer for the right door bonus amount. So this will help us specify the color and the amount of each door's bonus. So let's create another one for the left door. All right. Okay, perfect. We can also add 2 colors, so 2 new fields for the private color let's say bonus color, and okay, let's say bonus color and penalty color. So when the bonus will be negative, so if it's a difference or a division next, we will use this color for the doors renderers. Okay, perfect. So in the start method, we can call a configure method, configure doors, let's say. Okay, and let's create it. So let's say private void, because we don't want to return anything, configure doors. All right, perfect. So let's first configure the right door. Or maybe we can just specify all the elements in the inspector first. So let's drag the right door renderer and drop it here. Same thing for the left door renderer. And while we're here, let's rename this. So it's left door renderer. This one is right door text. And this one is left door text. Okay, sorry. Let's do this and this. Okay, perfect. So let's specify these door texts here in the inspector. So drag them and drop them here. All right. So the right door will have an addition bonus of, let's say, 20. And the left door will have a difference bonus or of, let's say 10 for now. The bonus color will be something bluish. All right. And the penalty color will be kind of red. Okay, perfect. So let's go back to our script here and start configuring the doors. So let's add a comment here that will say configure the right door. All right. So let's configure the color first. So we can say if right door bonus type equals bonus type dot addition, we can say that the right door renderer dot color equals bonus color. Okay. Then we can say right door text dot text equals plus the amount of the bonus. Append this string to the right door bonus amount. Perfect. Else if, let's add another condition. If the right door bonus type equals difference, then the color of our right door, so right door renderer.color, will be the penalty color. Okay. And regarding the text of the right door, it will be minus the right door bonus amount. Perfect. Let's try if the first door is working first. So let's hit play. Perfect. We can see now plus 20. Okay, let's try a difference for the right door. -5, let's say. Hit play. -5, and the color turned red. Awesome. Let's do the same thing for the left door now. Okay, so let's add another comment. Configure the left door. Okay, we can grab all of these lines and pass them right here. So it's going to be left door bonus type. Here, left door renderer, left door text, and left door bonus amount. Okay, perfect. So we can just replace all of these two. All right, let's hit play. Let's go back to Unity first and hit play. So we should have -5 and -10. Awesome, it's working. Now the player is not colliding with the doors because we don't have any collider or any way to interact with the doors for now. Okay, cool. Let's add the multiplication and the division too. So here in the bonus type enum, we can add multiplication and division, or let's say product instead. So product and division. Okay, perfect. In the configure doors method, we can either keep our logic here using if and else if, so conditions, or we can use a switch condition. So just to show you how it works, let's use it. So right here, we can comment this first, sorry, okay. Let's comment it like so. And let's use a switch. So switch right door bonus type. So depending on the right door bonus type, what are we going to do? In case the right bonus type is equals to bonus type dot addition, we are going to do stuff right here. Let's add the 4 cases. So let's add bonus type dot difference, bonus type dot product, and bonus type dot division. All right, so now we have our 4 possibilities for the right door. So if it's an addition, we know that we need to do that. So let's grab this and paste it here. Okay, for the difference, we have the logic too. So let's grab it and drop it here. We can add these 2 lines to the division and add some small changes here. So let's add the divided maybe character. And for the product, same thing. We can take the addition lines and drop them here. Although here we need to change the plus sign by a X sign, which means product. Okay, perfect. So we can also remove these lines now and these ones. All right, we can copy all the switch function here and paste it here because we are going to use it for the left door too. So let's say here left door bonus type. We are going to change the left door renderer. We're going to change the left door text and the left door bonus amount. So we need to change this for all the 4 cases of the left door. Okay, let me change it quickly. All right, perfect. Let's now go back to Unity. And now you can see that we can also select the product and division. So let's say the right door will have times 9 and the left door will have divided by 2. Okay, let's hit play. Perfect, working properly, guys. In the next session, we are going to see how the player can interact with these doors. All right, see you there. All right, guys, we are now going to add the logic for our doors. So the first thing we want to do here is select the doors game object and add a new component to it. This component will be a box collider. So right after you add it, you can see a green outline here, in a green box outline. So this is a collider and will help us detect collisions between the doors and the player. So let me move it along the y-axis by moving the center Y position right here. All right, let's increase its scale on the y-axis to something like that, and also increase its scale on the x-axis. Okay, perfect. Let's say so 10. I think 10 is the width of the doors. Perfect. And let's make it less deeper. So like so maybe. Yeah, perfect. All right. So let's tick the trigger checkbox because we don't want the player to collide with these doors. We just want him to pass through them. Okay, cool. So now let's go back to our player. Here it is. And let's add a new script. So in the scripts folder, let's create a new script and call it player detection. This script will be in charge of detecting collisions or trigger enters with any object in the world and do something. Okay, so let's drag and drop it onto the player and open it. Perfect. Let's create a new method, private void, and let's call it detect doors. All right. Then we're going to say collider. So let's create a new array of colliders and let's call it detected colliders. So this will hold all the colliders we detect by using a method that we're going to write right now equals physics. So let's access the physics class dot overlap sphere, and this overlap sphere method allows us to create in a sort a sphere around the player or around any position we want and detect things inside of this sphere. So the center of the sphere will be transform.position, which is the position of the player, and the radius of the sphere for now, let's say 1. All right. So now Unity will store any collider inside this sphere in this array. Okay. Now we can loop through this array. So use a for loop from 0 to the detected collider's length and see if there is any door inside of these colliders. Let's add an if statement. If detected colliders I, we grab the I index of the detected colliders, dot try get component. We're going to try and get the component and store it in doors. Okay, this way, if Unity detects a doors component attached to this specified collider, it will execute this code. So now we can use our doors here. Okay, perfect. So for now, let's just debug.log to write something in the console. We hit some doors. Okay, so now we can call our detect doors method in the update method, like so, and go back to Unity to see if the player can detect doors. So let's hit play. Let's open the console too. And here you can see that we hit some doors 181 times. So if the game is 60 FPS, it means that we were hitting doors for 3 seconds. Okay, perfect. So whenever the player hits the doors, we want to grab the player's local position. So if it's on the right side of the road, it's going to trigger the right door. And if it's on the left side of the road, it's going to trigger the left doors. So this is exactly what we are going to do. Okay, so to do so, we need the doors to return this info. So which door did we hit? So let's call doors.getBonus with the X position of the player. So transform.position.x. But we will need two pieces of data here. We need the bonus type and the amount of the bonus. So there are multiple ways we can do this. We can create a bonus structure or class, or we can grab the two datas by saying int bonus amount equals here and create a new method in the doors script to get the bonus amount and create another one to get the bonus type. So let's use this method because it seems to me that it's the easiest one to start with. So in the doors script, we're going to set the bonus type to public. This way we can access it from other scripts. And we can also drag it all the way up before we specify the class so that we can use it anywhere without specifying the doors class. So right now we can say bonus type right here, you see, without specifying the doors class. Bonus type equals doors.get bonus type at this exact position. Okay, so now let's create these two methods here. So we can go in the door script and create a new method called, first off, it's going to be public because we're calling it from outside of the doors class, integer get bonus amount at a specified position, so float x position. Okay, so here we can say if x position is greater than 0, let's return the right door bonus amount. Return right door bonus amount. Else we can return the left door bonus amount. And same thing for the bonus type. So let's create a new public method to get the bonus type. So bonus type, get bonus type for a specific x position. Okay, so same thing here. If X position is greater than 0, we want to return the right door bonus type. Here I forgot return. Okay, else we want to return the left door bonus type. Okay, I hope you get it. So in the player detection script now, we've got our two pieces of data. So we want to send them to the crowd system because it is the script managing our crowd. So let's say crowd system dot, apply bonus, and let's send the bonus type and the bonus amount. Okay, now we need to specify our crowd system here. So let's create a new variable for this. Let's add an elements header. So elements, serialized field, private, crowd system. Okay, perfect. Now we need to create this method in the crowd system script. So let's copy it, go to the crowd system script and create a new method right here. Public one, because we are calling it from outside of the crowd system. Void, we don't want to return anything, and apply bonus. So it will take a bonus type and a bonus amount as an integer. Okay, perfect. Now we shouldn't have an error here. Perfect. Let's go back to our crowd system. All right, now we need to apply the bonus. So let's create a switch condition again. Switch bonus type. So case bonus type dot addition. What do we want to do? If the bonus type is an addition, we want to add some runners. So let's say add runners, and we will add a bonus amount of runners. Okay, so let's create a new method to add the runners. So let's say add runners int amount. This way we can call this method from this script and add as many runners as we wish. So for this, we are just going to instantiate the runners. So we need a reference to our runner prefab to be able to instantiate it. So let's create it. In the elements, let's create a new serialized field, private, and let's call it, it's going to be a simple game object, and let's call it runner prefab. Okay, perfect. Nice. Here, we want to create a for loop from 0 to the amount of runners we want to create or instantiate, and just instantiate our runner prefab under our runner's parent for it to be added to the crowd. All right, let's try this out. So I'm going to go back to Unity, and for now I'm going to switch the two doors to additions. Okay, this one will add 1 and this one will add 2 runners. So let's select the player. Let's grab our crowd system and drop it into the crowd system variable or reference here in the player detection, and hit play. And it's not working again because we forgot, of course, to add the runner prefabs. Okay, player runner. Let's try now, +1. I think it's adding more than 1, but at least it's adding runners. All right. So why do you think we've added more than 1 runner here? Okay, here is the solution. It's because we have been hitting the door multiple times here. If you noticed, we hit it 88 times. So it added 88 runners to the amount of runners we initially had, which was 12. To prevent this, we want to add some logic. When the player hits the door gets disabled. Okay, so let's do that. So right here in the player detection, we can say, once we've got our data, we can say doors.disable. And now we need to create this method disable in the doors script. So let's open it and create a new public method because we're calling it again from the player detection script, which is outside of the doors class. And let's call it disable. All right. So to disable it, we can just add an element which will be the collider of our doors. So let's create a new collider and let's call it doors collider or simply collider. All right. And in the disable method down there, we can say collider.enabled equals false. This way we are disabling the collider of the doors. All right, let's select our doors and drag the box collider and drop it in the reference here. Okay, let's hit play. Now we should only add one runner, which is the case. Perfect. Let's try adding maybe 20 runners on the left door. Okay, so we should have 32 runners. Nice. Awesome. It's working properly. So now we can add the logic for the difference, the product, and the division. Okay, so let's go back to our crowd system right here and add more cases here. So case bonus type dot product. Let's add the product because we already have the add runners method. Okay, so we will break it here. How many runners are we going to add? So let's say add runners and runners to add here, because we're going to create a new integer called runners to add equals blah, blah, blah for the moment. So we need to specify how many runners we're going to add. Oh, sorry, it's runners to add here. So if it's a product, if we have 10 runners and the door is ×2, we should have 20 runners. Okay. This means that the runners to add amount is going to be equals to our current runner count, so runners parent.child count, times the bonus amount, like so, minus the amount of runners we already have, runners parent.child count again. Perfect. Let's try it out. So let's say that the right door is going to be a product of 3 maybe. Okay, so if we have 12 runners, it should be 36. Perfect. Nice, it's working, guys. All right, let's now add the division, or let's add the difference first. Okay, case bonus type dot difference. Okay, let's break it here. So now instead of adding runners, we want to add a new method called remove runners. So let's make it private, void remove runners. And now we want to specify an amount of runners we want to remove. Okay, so before removing anything, we want to check if the amount of runners we want to remove is greater than the amount we already have or less. Because if it's greater, we should have 0 runners, not a negative amount of runners. So if amount is greater than the amount of runners we already have, so runners parent.child count, then the amount should be equals to the runners parent.child count. It shouldn't be greater than it. All right, perfect. And to remove a runner, we are going to create a for loop, but this time we are not going to start from 0 here. We're going to start from the index runners parent.child count -1. Okay, so let's specify it right here. So int runners amount is going to be equals to the runners parent.child count. Okay, and let's drop it here because this might change over time. And while I is greater now than the runners amount minus the amount we want to subtract, let's diminish I. Oh, sorry, here it's runners amount -1 because we want to start from the last runner. And we are simply going to destroy our runners parent dot get child I dot game object. But before destroying it, there is some logic in Unity. It's better to create a new transform, runner to destroy, let's say, and let's set it to runners parent dot get child I. So this is the transform of the runner we want to destroy. Then we want to unparent it from the runner's parent just to avoid some issues. So runner to destroy dot set parent null. This allows us to set a null parent. Okay, and then we want to destroy it, to actually destroy it. So let's replace this by this. Okay, perfect. Now we can call it in the difference case right here. So difference, we'll simply call remove runner and the amount of runners we want to remove. So it's going to be the bonus amount, and here it should be remove runners. Okay, you can type Control R two times to modify any instance of the method's name or any variable. It allows you to change them all at once. Okay, perfect. Okay, let's go back to Unity now and add a difference for the right door, and let's subtract 3 runners from the amount we already have. And it's not working. It means that we need here to specify greater or equals to the runner's amount minus the amount. And now it should work properly. And perfect, we now have 9 runners. Nice, let's add the division and we are done for this session. Because this one was kind of long, I'm sorry. But yeah, if you are stuck or something, let me know in the comment section. I will try to do my best and help. So if it's a division, okay, let's again specify the runners to remove. Okay, equals blah 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 that we are going to calculate right now, and let's remove them and break. Okay, perfect. So if it's a division, how many runners do we want to remove? So it's almost the same logic as the products, but in the opposite order. So let's say runners parent dot child count minus the runners parent dot child count divided by the bonus amount, and we're done. Let's try it. So let's say that the left door will have a division of we have 12 runners, so let's say divided by 3, and we should have 4 runners left. Okay, let's try. All right, perfect, guys. We now have the logic for the doors. So in the next session, we are going to see how we can make a prefab out of these doors and use them to create a full level, a full procedural level. That's awesome. Let's see you there. All right, guys. So last time we've added interactions between the player, the runners, and the doors. So now we're going to see how we can create a full level out of this. So let's grab our doors and drag them into the prefabs folder. All right, perfect. Let's remove them from the scene. And let's now open the chunks folder. We're going to grab the short chunk and duplicate it by pressing Ctrl D. Let's rename it short chunk 00, for instance, and double click it. Okay, perfect. Let's make the scene view a bit bigger. All right, perfect. Now we can go to the prefabs folder and grab the doors and drop them into the short chunk. Let's reset the Z component. All right, now we have created a brand new chunk made of a short chunk and the doors prefab. And we can use it to create a level. So these doors will have, let's say, an addition of 5 and a difference of 3. All right, let's create another chunk. So open the chunks folder. Let's create this time a medium chunk. So I'm just duplicating it. And let's call it medium chunk 00. Let's open it. And same thing here. We can grab our doors and drop them in the scene. All right. So this one will have the right door will have a product of 10 maybe, and the left door a division of 5. All right, perfect. Same thing for the other chunks. So let's open the chunks folder, duplicate the long chunk, rename it, and open it. Drag the doors in the scene, and here this chunk is quite long, so we can place 2 doors. So let's keep this one here, duplicate it and drop it here, and then we can change the values here. So let's add 20 on the left door and only add 5 on the right door. Okay, cool. Now we can go back to our scene, click on the chunk manager and drag and drop our chunks right here. So we can lock the inspector here, go to our chunks folder, I think we can, let's remove this one first. Okay, let's delete this array element and remove it from here. Remove this one too. Okay, perfect. Let's grab our short chunk first. Then we can add our medium chunk, maybe our long chunk. Then it's going to go back to the short one, then the medium one, and again the medium one. Yeah, let's do that as many times as you wish and hit play. Okay, let's make this one bigger. Now we can see that we have multiple doors. That's nice. Okay, let's increase the speed of the player because it's quite slow for now. So move speed, let's say 10. Let's hit play. All right, much better. 14, it's 140. Oh, that's awesome. That's perfect, guys. All right. So in the next session, we are going to see how we can create a finish line or add a finish line to our game to be able to loop through the game, to create what's called a call loop for our game. So see you there. All right. So now we are going to add a finish line to our game, and we're going to create its logic too. So when the player hits the finish line, it should automatically restart the game. All right, perfect. So let's open our photo editor here and create a new square. So it's going to be maybe 128 by 128 pixels. All right, let's zoom in a bit. Then let's create another one, but this one is going to be black. Let's create it like so. So just half of the bigger square. It's going to be a quarter of the bigger square. And let's create another one right here. Perfect. Now we have our finish line texture. So let's grab this and export it to our project. Okay, let's call it finish line. Yeah, finish line is good. And let's jump back to Unity. Perfect. Now we should have it in the sprites folder. Cool. All right. Now let's open the prefabs folder, open the chunks folder, and create a new, let's say, long chunk. So duplicate it and call it finish chunk. Perfect. Let's open it. Okay, let's make the scene view a bit bigger, like so. All right. Nice. So now we want to create a new game object, and this is going to be a quad. So it's basically a plane, but with less vertices. And we're going to rotate it. So let's focus on it first. Okay, let's rotate it along the x-axis like so. And let's try and apply, let's remove the collider first because we won't be using this one. So let's remove it. Then we want to create a new material for it. So go to the materials folder, create a new material called finish line. Perfect. Let's now assign this material to our new finish line. Cool. Okay. Now we can click on this little circle to assign a texture to our object. So we are going to select the finish line. All right. That's nice. Then you want to make the finish line to be as wide as the road. So let's select it and set a width of 10. Perfect. Let's make it a bit higher like so, maybe 0.2. All right. Okay, let's center it on the road. Let's make it a bit further. Yeah, let's say right here is good. Okay, nice. So now you can see that the texture is kind of stretched. To fix this, you can select the material and increase the tiling on the x-axis of the texture, like so. So for it to keep the same proportions, you want to multiply this by 10 because we set 10 for the width of the finish line. Okay, perfect. So now let's rename this quad to finish line renderer. Right. Then you want to create a new game object as a parent of this finish line and call it finish line. All right. We can add a box collider to this to be able to detect collisions between the finish line and the player. Okay, so now I need to grab this and center it along the finish line, like so, and then I can grab the whole object and put it at the same position it was before. All right, nice. You can resize the box collider here by checking this box. Okay, so let's resize it a bit. It's going to be a bit taller and wider, of course, as wide as the road. So it's going to be 10 on the scale, something like that. Perfect. Okay, let's set this collider to be a trigger as we did for the doors previously. And we're all done, I guess. Except we need to specify something for us to detect that this is a finish line. So to do that, we can add a tag here. So adding a tag to the finish line will allow us to check if the tag of the thing we've collided with is finished, and if so, we can apply some logic. Perfect. So let's select the player controller again. Player detection, sorry, double click on it. And in the detect doors method, when we are detecting the colliders, so we can diminish this because it's the doors logic, we can also check, we can say else if. So if that's not a door, check if it's something else. Else if detected colliders.i.tag equals finish. So if the object we've collided with has the finish tag, then debug.log, we've hit the finish line. All right, let's check if this works properly. So to do that, we need to specify our finish chunk in the chunks prefab array here in the chunk manager. So let's make the level only 3 chunks long, and the third chunk will be the finish chunk. But if you remember well, by opening the chunk manager, you can see that we were creating the level randomly. So we are going to fix this. We can create a new method here called, let's say, create random level. And we can grab all of this data here and paste it here. So this will allow us to keep the logic for creating a random level in case we need it later. All right. So now we need to create another method here to create an ordered level. Okay, perfect. It's kind of going to be almost the same logic. So we can grab our chunk position. We can grab this loop and drop it here. But here we're going to create a loop going from 0 to the amount of chunks we have. So from 0 to chunk prefabs.length. Okay, or we can create another array here, and I think it's a better solution. So let's make it private. Let's call it chunk, and let's call it level chunks. Okay, perfect. Now we can use it right here. So let's say level chunks.length. And now when selecting the chunk we want to create, we're going to say level chunks instead, and not random, but index I. Okay, cool. And I think we're pretty much done. So now we can call the create ordered level in the start method, and it should be working properly now. So let's select the long chunk again. We should see a long chunk first, then we should see a medium chunk. So both of these are empty, and then a finish chunk. Okay, let's hit play. Perfect. Long chunk, medium chunk, and finish chunk. Okay, so now when hitting the finish line, we should see a debug line right here. Perfect. We've hit the finish line. All right. So what we want to do for now is whenever we hit the finish line, we want to restart the game to get our core loop. Okay, so go back to the player detection script right here. And now we want to use a Unity library, which is called Unity Engine.Scene Management. So to make things simpler, we are just going to reload the same scene again and again whenever we hit the finish line. So let's say scene manager.load scene index 0. Okay, cool. Let's go back to Unity. So why did I say index 0? Because if you click on file right here and select build settings, you can see that our sample scene which is the one we are using here, it has the index 0. So let's hit play. Okay, wait for the player to hit the finish line. And when he does, the scene should restart. Like so. Perfect. So now you can imagine that if we add doors and enemies to this game, along with some UI, we can have a pretty much complete game with a call loop, and yeah, that's pretty much it. So in the next session, let's create a game manager and some UI to be able to prevent the player from running from the start, and just to better feel that this is a game, because it feels empty right now. So let's jump right into it.
Thank you for watching. Subscribe now and press the bell icon. Never miss any update.